Okay, so domain and range is our goal here. And the question says we have 24 meters of fencing, but this fence is going to back onto a barn. So we're really only going to use 3 sides of a fence. The very first question says express area as a function of width. So like I said before, we always want to draw a picture. So this is going to represent our barn, this red line here. And then our black solid line is going to represent our fencing. All right? This is going to look maybe something like this. Now, normally when we write this type of stuff out, this would be considered the width. This will be the length. And we don't have to use any fencing here because the barn covers that part, right? That makes sense so far? They've also told us that the perimeter, so all of our fencing together, is equal to 24. Well, all of our fencing altogether is going to be this width plus this length. So in other words, our perimeter is equal to W plus L. We know the total perimeter is 24, so we can replace P with that. 24 is equal to, and we simplify this to become 2W. 2W plus L is equal to 24. Okay, so there's our perimeter formula. Question says express area, which is something different, as a function of width. Okay, well, area is normally length times width. Okay? But the problem here is there's a length in here, and they want us to only express it as width. So in other words, we have to find an equivalent function or equivalent expression to length that includes just our width. Well, we can do that because of our perimeter formula. What we're going to do is we're going to isolate for L. We're going to move the 2W to the other side. So when we do that, we'll get 24 minus 2W is equal to L. Okay? So in other words, we can replace L with this equation here. Okay? So in other words, I'm going to redraw this. Here's our fencing again. And we need our barn. Where's our barn going across? So instead of writing L as L, because they only want it as width, these will still stay the same as widths. But this represents that L we were talking about before. So this part of the fencing is called 24 minus 2W. Okay? So now that we've done that, we replace the L in our equation. So our area is equal to, and area is, remember, length times width. Well, we replace L with 24 minus 2W times W. Okay? And that's it. I could technically distribute this, but unless they say expand and simplify the answer, this is technically an expression of area in regards to width only. There's no lengths involved here.
So is that the answer?
That would be the answer to A. That's acceptable for A. Okay? So for part A, here's your answer. Okay? We'll talk about the quadratic stuff after. So we've already done part A. Part B, determine the domain and range. So we got to find the maximum and minimum possible widths of this fencing here. In other words, area can go up, right? We can take area in a positive direction to be billions and billions, but area can never be what? It can never be a negative value, and it also can't be zero either. We can't have zero area. So because our kind of cutoff there is we know it can't be 0 or lower, we're going to replace area with the number 0. Okay, and we're going to find out what values would give us an area of 0. So if A was equal to 0, we'd have 0 equals 24 minus 2W times W. Okay, now in order to create a 0, these are two values multiplied by each other. One of these must be 0, so we're going to split this equation. So we get 24 minus 2W equals 0. Does this make sense so far? Yeah. And W equals 0. Okay, well, yeah, we know width being 0 would give us a 0 area. Let's figure out the other one, and this is where I made a mistake in the last one here. We got to isolate for W. So when we bring 24 over, we'll have negative 2W is equal to negative 24. That's okay. And then when we divide by negative 2, W equals what? 12. Or a little different, because remember I said there was a bit of error in the other one? 0 and 12. So these are supposed to be our largest we can make things.
Yeah.
And this is going to make sense when we go to plug them in. So remember this being width. Well, if width is 0, so I kind of draw a smaller version of this. My two widths are 0. This would become 24 minus 2 times 0. I replace the width with 0. 2 times 0 is 0, so we get 24. Well, you can't have a width of a garden be 0. So we would just be using, and if this was 24 meters long, it would just be a straight line. We haven't made a garden. So we know 0 is too low. Our other one was saying a width of 12. Okay. Well, we can have a width of 12 and a width of 12. That makes sense. And our formula was 24 minus 2 times the width. So 2 times the width is 12, right?
Yeah.
So what's 2 times 12?
24.
So we get 24 minus 24. Can I have a length of 0? No, that doesn't make sense either. All I have now are two things on the outside being 12. Okay? So neither of those make sense. So in other words, we have to get values that are between these two.
So less than.
It has to be greater than 0 and less than 12. So when they're talking about domain,
Not vice versa.
Yeah.
our domain is x is element of all real numbers such that x is greater than 0. It's not equal to because 0 is no good.
Yeah.
And it has to be less than 12. Again, not equal to because 12 would give us nothing. So there's our domain. It has to be between 0 and 12.
Yeah.
But they did ask us another thing. Range.
Don't you need to know the picture to find range?
What's that?
Don't you need to know the picture to find range?
The fixture?
The picture.
We have a picture.
Like
We can figure out range too. I want to go back to this part of the equation. Okay? We're going to figure it out right now. I'm going to take that equation there. I'm going to rewrite it. Area was equal to, what did we say it was? 24 minus 2w times w, right? 24 minus 2w times w. Well, I'm going to expand this just so we can get an idea of what type of function this is. Well, this becomes 24w minus 2w squared. Well, this is, do you know what type of function this is?
Quadratic.
It's quadratic. So what did we find before, this 0 and this 12? We factored and got values when a was equal to 0. What is that considered in a quadratic?
X-intercepts.
X-intercepts. That's exactly what we found. So we just discovered that one x-intercept was at 0 and the other one was at 12. Okay? Our a value is negative, so which way is this quadratic face?
Down.
Down. So we have some quadratic like this.
So to find the vertex.
We have to find the vertex for the range. Well, if we have the two x-intercepts, how can I find the vertex?
You add them together.
Okay.
Divided by 2.
Yeah, so it's called the axis of symmetry, is known as adding r plus s divided by 2.
Yeah.
So we have 12 plus 0 divided by 2. What does that give us? 6. So we know our x value is going to be 6.
So then we need to know y value.
How do we find the y value from
So
this?
sub it back in.
You sub it. Yeah.
Sub it right back into this equation. Great. So the area is equal to 24 minus 2. We replace w with 6. Or I could have done this equation here. Either of them are fine, okay? And then times 6. So this is going to find our max area. 6 times 2 is what?
Oh.
12. So we have 24 minus 12. What's that going to give us?
12.
Okay, and then we have 12 times 6.
72.
72. So your max y value is 72. So what is our range in this case?
Range.
Range is,
Less than.
you always got to put this. Y is the element of all real numbers such that, I'm going to move it down a little.
Y. Y is less than or equal to?
Okay, so what was the lowest part of the range?
They're like yours now, isn't it?
Well, we can't have, the range deals with what? It deals with
the
area,
fence,
right?
So it can't be
Oh.
negative.
We can't have an area that's negative. You're right, in a quadratic there's no lower part, but in realism when we're talking about the area of a fence, we can't have a negative fence.
Yeah.
So if I was just talking about the range of this quadratic, you're right, there wouldn't be no bottom. But because we are talking about an actual measurement of something, I can't go below 0. In fact, I can't have what number?
0.
We can't have 0 either.
So
must
Greater
be
than 0
That's
and
right.
less or equal to 72.
That's right. It is equal to 72. 72 is its max value.
Ew.
Okay.
That's like programming.
Yeah.
Use it on a lot.
Okay. So there's quite a bit to that. Does that make sense?
Yes.
Quite a bit to that question, though.
Yes, seriously.
Actually, I made this